In this session we're going to be applying all the work we've done previously on the different types of angles and the different types of lines, and using this to understand the types of lines and angles that create 2D shapes. So we're going to be able to use this information to describe the properties of these two-dimensional shapes. Turning to our textbook, we can see that our first problem relates to a PE lesson in the hall and the activity that the children are currently doing. We can see that the teachers asked the class to make a quadrilateral, and question 1a asks, what type of quadrilateral have the children made? And how many pairs of parallel lines does this shape have? So in order to answer this question, we're going to think about the definition of those two words. So what is a quadrilateral and what are parallel lines? And then secondly, once you've identified those two things, then we're going to be thinking about how you can check whether any lines of this shape are parallel. For question 1b, we're asking, do other sides of this shape have a different number of parallel lines? So when you've worked out what this quadrilateral is, if we made it different sizes, would we still have the same number of parallel lines or different? So now it's time to pause the video and to give those two questions a go. So question 1a, what type of quadrilateral have the children made? And how many pairs of parallel lines does this shape have? And for question 1b, do other sizes of this shape have a different number of parallel lines? So pause the video, give this one a go, and come back and join me when you're ready to look at our strategies. So let's begin by looking at question 1a. What type of quadrilateral have the children made? And how many pairs of parallel lines does this shape have? Now we can answer the first part of this question, what type of quadrilateral have the children made, by using a line to draw the shape. And we can see that a quadrilateral is a four-sided shape, the word quad meaning four. And looking at this, we can see that the children have made a shape which is one child high and two children wide. So knowing my 2D shapes and their properties, I know that this shape is a rectangle or an oblong. And here you can see that a little bit more clearly, so 1 unit high and 2 units wide. Now let's move on to the second part of this question. How many pairs of parallel lines does this shape have? Well, if we remember our learning previously, we looked at the idea of a parallel line was a set of straight lines that travelled in the same distance, be that horizontally or vertically, that remain exactly the same distance apart. And we can see on this rectangle that I've labelled two pairs of lines. So the first pair are the red vertical lines, and you can see they are exactly the same distance apart at the top and the bottom. And the second pair, in black, you can see are exactly the same distance from the top and the bottom from both ends. So we can see that we have one pair of parallel lines that are vertical in red and one pair of parallel lines that are horizontal in black. So how many pairs of parallel lines does this shape have? It has two pairs. Because we need to remember that parallel lines we count as pairs, not as individual lines. They're only parallel when there's two of them. For question 1b, we were asked, do other sizes of this shape have a different number of parallel lines? And here you can see our original shape of 1 unit high and 2 units wide, and this has opposite sides which are parallel, so there's two pairs. There's the pair of vertical lines that are parallel and the pair of horizontal lines that are parallel. Now I've created a smaller quadrilateral, a four-sided shape. This one's 1 unit high and 1 unit wide, and again you can see that my horizontal lines are parallel, they're always the same distance apart, and my vertical lines are parallel, always the same distance apart. So though this is a smaller shape, we still have opposite sides which are parallel, so two pairs of parallel sides. And here we've got a third quadrilateral. This one is 2 units high by 1 unit wide, and again you can see that my horizontal lines again are still parallel, so they're still with equal distance apart all the time. And you can see that my vertical lines, well, they are parallel as well, always remaining exactly the same length. So we can see that with a quadrilateral like this, a four-sided shape, we're always going to have two pairs of parallel sides. So in answer to question 1b, do other sizes of this shape have a different number of parallel lines? Well, if we're creating a rectangle or a square quadrilateral, then we will always have two pairs of parallel lines. Now, just out of interest, could I make a quadrilateral that does not have two pairs of parallel lines? Pause the video for a moment and see whether you can test that out to see whether all quadrilaterals, all four-sided shapes, have two pairs of parallel lines, or whether you can create one which doesn't match that criteria. So hopefully you've discovered that in order for us to have parallel sides, we also need perpendiculars. So it means we're looking at quadrilaterals with right angles for this. So if you were a trapezium or a rhombus, then you don't necessarily need to have two sets of parallel sides. And that leads us on to the next question from our textbook, our Think Together, which involves our rectangles again. And our question here is, how many pairs of perpendicular lines have the children made? And we're given the tip. I will draw some other rectangles on squared paper to check if the answer is always the same. So once you've given this a go, thinking about that definition of perpendicular we've looked at in previous lessons, and remembering the work we've just done on parallel, then you're ready to complete the textbook questions before moving on to the independent work from the workbook. So good luck with this, and I look forward to seeing the work you create.